Welcome, and moving on with getting deeper understanding of artificial intelligence agents, we want to turn to a situation whereby, since we've discussed quite a number of different kind of agents, problems which might have, we find that there are situations where an agent might be faced with quite a number of possible actions it can do. So the agents need certain special techniques of search. Here, what we just want to try to understand is how an agent can find a sequence of actions that achieve its goals when no single action will do. So there are quite a number of search techniques which are there, but we will just look at a few. But the basic in designing this agent is that we understand that how do we go about designing such. So of the four agents which we described, the simplest one, the simple reflex agent. These ones base their actions on a direct mapping from states to actions. Such agents cannot operate well in environments for which this mapping will be too large to store and will take too long to learn. So we tend to concentrate more on a kind of particular goal-based agent called a problem-solving agent. We discussed about the goal-based agent before. So this problem solving agent, kind of goal-based agent, on the other hand, it considers the future actions and the desirability of their outcome. It's able to decide first on what on quite a number of possible actions, to also consider what might happen if it might take certain actions. So to achieve this now, it means there should be a way of representing those particular states and actions that can be taken on the states. So they use atomic representation, that is, the states of the world are considered as wholes with no internal structure visible to the problem solving algorithm. So we just consider a state as a particular whole without the internals. And the other kind of agents that might be looked or more into the state are certain goal-based agents that used more advanced factored or structured representations. So these are usually called planning agents. They are there also, but as we are building, we come to an understanding that in this situation, the state is being considered as a whole. So to understand these agents, we describe several general purpose search algorithms that can be used to solve these problems. Quite a number of search patterns and search techniques that are there. So we will discuss basic ones, and there are quite more. We can spend a lot of time, but the basic is to get the concept behind. So we have several informed search algorithms. Algorithms that are given algorithms that are given no information about the problem other than its definition, whereas on the other end we've got informed search algorithm. On the other end, this can do quite well given some guidance on where to look for solutions. So these techniques of being uninformed and informed also affects how the algorithm will perform. It's the nature and the type of the algorithm. So the procedure, what we do first on such agents is to formulate goals. We call it goal formulation. So given a problem, we have to come up with goals. So goals help organize behavior by limiting objectives that the agent is trying to achieve, and hence the actions it needs to consider. Goal formulation based on the current situation and the agent's performance measure is the first step in problem solving. So in terms of solving a particular problem, we need to be able to analyze it and formulate goals. That's what is very important in this kind of agents. We'll consider a goal to be a set of world states, as we said that the states are atomic, exactly those states in which the goal is satisfied. The agent's task is to find out how to act now and in the future so that it reaches a goal state. So before the agent can do this, the agent needs to decide what sort of actions and steps it should consider. So the problem formulation now it's a process of deciding what actions and steps to consider given a particular goal. So we need to be able to filter, encapsulate, to try to come up with a representation summarized and very necessary for the particular problem. For example, let's assume that the agent will consider actions at the level of driving from one major town to another. Each state therefore corresponds to being in a particular town. Let's say the agents would want to travel from one town to another. There are many different towns to pass by. So all those other towns which it passes by, we might regard them as other states. And for example, from one particular source, there are 4 roads leading from the starting city, and none of the roads achieves the goal of reaching the other city unless it's familiar with the geography. That is, the agent will not know which one is best to take on those possible routes to start from a particular source or starting point towards to achieving its goal. So the agent has no additional information. It has no option than to try one of the actions randomly. So if the agent have a map, that is the map, it will be providing the information about the states it might get into its action. It can use it to try and find possible route. Once it finds a route, it can achieve its goal by carrying out the driving action. So you notice here that the whole idea behind this stage as we get into more understanding on this is to try to formulate a goal. It is these goals now which we want to fit in the program structures which we have discussed before. So for us to be able to do this in terms of formulating these goals, and we have to make certain assumptions on the environment. We assume that the environment is observable. That is when the agent knows the current state which it can observe. And we also assume it is discrete. When we say discrete, we mean there are finite actions to choose at a particular state, and also the environment is known. That is, the agent knows the states reached, and also we assume that it's deterministic. The environment is deterministic. That is, each action have one particular outcome. Although these assumptions, we should note that the conditions are not always ideal. So the field will keep on growing as you try to incorporate much conditions. So under these assumptions, the solution to any problem is a fixed sequence of actions. The process of looking for a sequence of actions that reaches the goal is what we call search. So search becomes one very important field as far as the design and implementation of these agents is concerned. One have to understand very well, so that for you to be able to implement those programs, those programs will be implemented in any particular language. For example, Python is most common use, but I wouldn't limit one to implement in their program of speciality. A search algorithm takes a problem as input and returns a solution in the form of an action sequence. Once the solution is found, the action it recommends can be carried out. This is called the execution phase. So for this, for our agents, after describing such search criteria and goal formulation, you discover that basically the agent design follows a formulate, that is formulate the goals, search, and execute. That is like the design of our agent. So the implementation, when we go through the practical approach, is to then implement this. But what's important is to be able to design, come up with your structure and the goals, formulate, choose a particular search algorithm, then you implement. And I hope next we'll just look at particular search techniques. Thanking you. Let's continue in the